Alright, so this is the HL extension of OOP, although you'll see that most of this stuff is not about OOP. It's moving on from what we did in topic 5, so a lot of it will be a second iteration of that. So define the term recursion. You can see from past paper, there you go, a process that calls itself. And actually, what's wrong with that? And this is the marking scheme.
It calls another instance of itself.
Exactly. It should be it calls another instance of itself. So that's basically it, and I've got it right there. Thus, it is a form of iteration. Iteration means to repeat. Recursion will allow you to repeat something again and again and again. Point 2, describe the application of recursive algorithms. Students should understand that recursion can be applied to a small subset of programming problems to produce elegant solutions. Students should also understand that recursive algorithms are rarely used in practice. And I mentioned that a couple of times yesterday, and I think you get it already. And we have looked at a few examples, so I'll just list those examples. The Towers of Hanoi problem, the recursive binary search, moving through a tree, either pre or post or in order. So if you know those examples, you're probably good. And it wouldn't be a bad idea for me to add those there, but I'm not going to be fixing up notes today. 4.3, construct algorithms that use recursion. We did that right off the bat, the very first thing that we did. That is the construction of a recursive algorithm. That's a little bit of phraseology that you're going to have to get used to as we go forward if you don't get it already. But construct algorithms that use recursion, that's you with Java. And that's where the HL extension does assume the use of Java. And that's, I guess, where this is a little bit different than the HL topic 5, where you can use other programming languages if you want to. Here, the assumption is that you're using Java. And so what bumps this up from what we did in topic 5 is that you really do have to be able to do it with Java, which we already did. But that, sure enough, will work. So a quick review, in case people are jumping in to this without having taken a look at topic 5, is we are calling the recursive loop right here. It's taking in a 0. 0 is less than 10. We're printing out the 0. We're making that variable go up by 1. And then we're calling exactly the same name function again. So we're calling another instance of this. Only the second instance of this will not take in 0, as the first one did. It'll take in 1. And in that case, it'll still go into the first block, not to the else, because 1 is still less than 10. But you can imagine that as these are called again and again and again, sooner or later, what's being passed will be 10. And when what is passed to the 10th iteration of this method is 10, then this will be false. And so there will be no other recursive calls. That last one will just return and finish, which means that the one before that is then finished. The one before that is finished, and so on and so on and so on down through the stack until we get to the base initial call, and it also will have finished all of the recursive calls and go to the return, and everything will be done, and the result will be 10 print lines from 10 different recursive loop instances. And yeah, so I'm referring back to all those things that we did yesterday. This is where we can slow down, and I don't think I can do this with Photoshop, so anybody that's watching this video in 2015 and wants to learn this from me, you have, come on in after school or whatever, but I think what we'll do here is I'll actually show you guys on paper how to do it.